Welcome to Study Loop.
Hi, everybody. So for this one, we need to know what the projectile has a weight of 45 pounds, and with respect symmetry determines proximity rate of precession. B, if it's further known the radius of the gyration of the projectile, and determine the exact values of the two possible rates of precession. Okay. And we can start by kind of drawing a little image. My image, of course, is not going to be perfect, not super good. Sorry, I had something on my screen here. So there we go. And it looks like a little bullet. So, and here we have, that's what they show in the image. So I'm just copying the image that they have. But you can do your own image if it helps. But I like to kind of copy some of these images because it helps me think it through. And it's also just nice that someone helps, you with your thinking. Okay. And so it is moving this way. Okay. Because you know how a bullet is actually spinning. Okay. And from about here to here, we have D. And then here is beta, angle beta. And from about here to here, we have C. Okay. And so now express the drag force due to the force couple system. And so the drag force is going to equal to D. Oops, that does not look like a D, does it? Equal to D sine beta minus W cosine beta and I hat. Okay. And okay. So here the drag force is an atmospheric drag force. Okay. And we need to express the moment about G. So the moment here about G. And that's going to be expressed with mg equals D. Let me make I am sorry, I cannot write D's today, apparently. So D C sine beta J hat, okay? And now here the G is mg and distance between G is CP, okay? And so we have the theta equals beta equals 3 degrees. Okay, and express the moment about the mass center, and express the moment, and this actually has a little hat here, mg equals to I inertia wz minus inertia phi cosine theta phi. I wrote phi two different ways. There are two different ways to write phi. So you can either write phi like this or like this. So which other way? I like to call this the Disney phi because it looks like the Disney symbol. Okay, sine theta. And again, learning to write Greek letters, just write what's clear and precise for everyone else, but kind of figure out which way you like for yourself. And so now we have to compare these two. So what we're going to do is replace this here. Okay. So from that, we have dc sine beta j hat. And actually, we don't need the j hat here. Okay. And equals to I z minus I phi cosine theta. And yeah, I'm just saying the letters just because it's faster to say the equation when I just do that. And so we're going to call this equation 3. And so we got to express the angular velocity here. And that's going to be capital phi plus little phi cosine theta. And we're just going to plug that in here, and we're just going to scroll down. So we have dc sine beta, okay, equals inertia times phi plus little phi cosine theta, okay, minus I phi cosine theta phi sine theta. And let's simplify this. So we have dc equals I phi plus I for the inertia phi squared cosine theta minus I phi cosine theta. And I believe, have I been writing down the thing the wrong time this whole time? Just give me 1 second. Oops. And what we can do is actually replace this one up here with beta, because we did that here. So since I'm replacing that, there we go. And this actually cancels out with that. And that's what I was trying to figure out. Okay. Fix that. And I'm just going to do this. And here we have dc equals I phi minus I inertia minus inertia phi squared cosine theta. Okay. And so for this, we can neglect this term. And so what we'll do is we have I phi is about equivalent to dc. And so your phi is going to be about dc over I over capital Phi. And we also have m equals weight over gravity for the mass. So we have 45 pounds times 32.2 feet per second squared equals 1.3975 IB squared in feet. And this actually is equal to a slug. There we go. And we're just going to scroll down again. And we can express the axis spin. So we have the axis spin from the inertia here as mkz squared. And this is going to be 1.3975 times 2 inches, which is times feet divided by 12 inches squared. And in here we get 0.03882 slug feet squared. And now we can express your capital Phi, which is the rate of spin, as 2 pi n 60. So this is your rate of spin, okay? Here we go. And this one is 2 pi 6,000 RPM, okay, divided by 60. And we have 37,699.1118 divided by 60, and we get 628.32 radians per second. Okay, and now what we can do is A, and for A, what we can do is we go back up to finding our phi, And we're using this equation here. So we're going to bring that down here. And here we can just substitute what we have. So 25 pounds, 6 inches, times 1 feet divided by 12 inches, divided by 0.03882 slug feet squared times 6 to 8.32 radians per second. Okay. And this is going to equal to 0.512 radians per second. And we need to convert it to RPM. So it's 62 pi. And it's going to equal to 4.89 RPM. And that's the rate of precession. So we'll put rate of precession. Okay. And now for B, we have to find the moment of inertia about Kx, which looks like this. And in here we got 1.3975 times 8 divided by 12 squared equals 0.6211 slug feet squared. And now what we're going to do is plug this whole thing into our equation that we had up above. So we're going to plug it into this one right here. Okay, I'll give you a second to copy that down. Okay. So now I'm just going to write it out. So we have 25, 6 inches divided by 12 equals, and now we can write 0.03882 by 6 to 8.32 radians per second. And I'm just not going to put units here so it saves us time. But it's the same units that I used up above here. So you should already know it. You can write them down if it helps you out, okay? I'm just saving space. 0.6211 minus, oops. Let me fix that. There we go. Minus 0.03882 times phi squared times cosine to the 3 degrees. There we go. And we don't need to make that big. There we go. Okay, so you can obviously tell that we're trying to solve for this little guy, the phi. And we're just going to simplify 12.5 equals 24.391 phi minus 0.581 phi squared. And if we have it right, we have 0.581 phi squared minus 24.391 phi minus plus 12.5 equals 0. And we could actually do the classic formula here, quadratic formula, just to help us. This is one of those formulas that you think you would never use, but you use all the time in physics. So just remember it. It's a nice, it's a really nice formula that a lot of math uses for some reason, even high up math. So it's a good one to have remembered. So we have 24.391 plus or minus 24.391 squared minus 4 times 0.581 times 12.5 divided by 2 times 0.581. Oops. 5, okay. And here we get 24.391 plus or minus 23.775 divided by 1.163. And from this, you have 0.5189 radians per second, or 41.42 radians per second. You're not quite done. So now we got to convert these to RPMs. So we're just going to convert it to RPM. And what we're going to do is multiply both of these by 62 pi RPM radians per second. Okay, you just multiply these each by that. And so for the first one, you get 4.96 RPM. And the second one, we get 396 RPM. Okay? And those are your answers. Thank you, guys.